Okay, this is a amateur video on designing an experiment for psychology students and various factors to consider. It is not exhaustive and I hope you enjoy it. So what are the factors that we need to consider when we're designing an experiment? Not just a psychology experiment, but other experiments. Well, you need to consider your research question, your hypothesis or objectives, or what you want to do, what your tests will be and the limitations of those tests and how you could work upon those or mitigate them. And within that, what your dependent and independent variables are going to be. Then you're going to have to consider the number of trials. Normally this would be 3, but when you start looking into statistics, you want to consider things like effect size and power. And also, when you're working practically, you'd also want to consider the resources and time and money you have, among other things. Next, you'll have to consider things like bias and how you want to accurately record the results, as well as the next ethics, the ethical principles, which will be discussed later. So now moving on to what your research question would be. So the research question, you could do it in 2 ways, really. First of all, you could do it in terms of objectives, if it's like a descriptive piece of work, and there's not a lot of information out there. Maybe you just want to do a test on various people and then look at their ethnicity, look at their characteristics, and say and provide explanations for those, and then hand that over to other researchers to look into. But sometimes you might want to be a bit more specific. So, for example, if we use the example of the spatial intelligence test, perhaps you're working with a company that has developed a new energy drink that will improve your spatial intelligence scores. So you might want to compare that to a competitor's energy drink. And that would be an alternative hypothesis, with a null hypothesis being that there is no difference between your energy drink and your competitor's energy drink. Now, it should be noted that the alternative hypothesis tends to be mentioned within literature, but the null hypothesis isn't always stated and sometimes tends to be given. Now, this slide provides a framework known as the Pico Framework, which is sometimes quite useful when you're considering a hypothesis. Now, when you're considering a hypothesis, if you can make your test as specifically as possible, or specifically narrow down make the hypothesis as concise as possible, it makes your life a lot easier, and also makes it easier for other researchers to find your piece of work. So when you're doing this, you want to consider factors like your patient population, your intervention and exposure, what you're comparing it to, for example, a drug or a placebo, and what outcome you're measuring. So it could be spatial intelligence, or it could be self-esteem measures, it could be measures of depression, anything really. So this slide illustrates the points about considering the tests or interventions that you're doing in detail. So for example, when you look in psychology at spatial intelligence, there's various measures you could use to measure spatial intelligence, and this is of importance to a variety of stakeholders. So it could be educational psychologists, it could be public health specialists that are trying to improve the spatial intelligence of children who unfortunately haven't developed as much in comparison to their peers. But when you look at the different tests, each one has different pitfalls. So for example, one might argue that you could use a jigsaw to measure spatial intelligence, but then you'd have to consider the type of jigsaw. So for example, if the jigsaw is of a picture of a castle, and it just so happens that one of your participants has been to this castle before, they might be using a different part of their brain to solve that image. Furthermore, you also have to consider things like disabilities and individual differences, which we can't unfortunately always take into account. And also another example is asking someone to navigate blindfolded. So maybe you give them an energy drink and then you show them a room and then you blindfold them. and then you ask them to go around the room, try to remember this, and then have someone follow them to prevent injury, make sure they don't fall, etc. Well, that might be using a different part of their brain. So, for example, people that are making a jigsaw might be using the temporal lobe or something like that, but it's shown that when people navigate blindfolded, they might be using a different area of their brain, such as the hippocampal place neurons. So, as previously mentioned, when you're doing your study, you want to consider independent and dependent variables. So the independent variable will be the variable that you will be changing. So it could be the intervention, it could be the environment, it could be the stimulus. So for example, you want to measure how fear measures affect spatial intelligence. So for example, you have a participants that go towards a test, and then you pop a balloon, and they're not even aware of it, and then you ask them to complete the test, and you see how different people respond to that, or maybe different personality types respond to that. And then from that, you'll measure dependent variables. Now, depending on the time and the resources you have, it might be better to have to measure as many dependent variables as possible, because as previously mentioned, these will help you provide different explanations. So, for example, with a jigsaw, different individuals might take different amount of times to process the jigsaw, and this might be due to, for example, differences in their visual processing memory, or their reaction time mechanisms, or something to do with the genetics of their muscles. This may not actually be true, but this is just plausible. And ideally, you want to have at least 3 different trials. So adding on to that, coming back to using a jigsaw to measure spatial intelligence, you could look at, for example, the latency to start, how long it takes for them to start completing the jigsaw and process what they have in front of them, and also the maximum complexity jigsaw they can complete. It might be possible, if you just measured the latency to start the jigsaw, for example, but didn't measure the complexity, you might actually be missing out on information. So it is possible, for example, that people that take a lot of time to start piecing together the jigsaw might actually be able to complete a higher complexity jigsaw puzzle. So maybe they can do a 1,000-piece jigsaw, even though a person that starts completing the jigsaw might only be able to do a 200-piece jigsaw. So what are the factors? What are the extraneous or confounding factors that might affect our results? Well, these can be a variety of things. They could be extraneous factors, which are variables you can't control, which I'll explain, or confounding factors, which are areas that you could and should control to prevent confounding. And so the examples of confounding factors include things like age, ethnicity, maybe things like prior experience, what kind of job history they have. Now, explaining a little bit more about extraneous variables. So these are variables that you can't control but are likely to affect everyone. So if I'm doing a spatial intelligence test, it's possible that some people are taking energy drinks, or maybe their diet has an impact, or maybe they haven't slept well. Now, unfortunately, it's not possible to monitor someone 24/7 and consider all the individual differences or all aspects of their life. Although you might be able to ask them, so maybe if you have a participant that does really well, you could ask them, why do you think that you did so well on this jigsaw? And they might tell you, I'm a huge fan of jigsaw, I do it for a hobby. So that's why I completed it so quickly. Now, it is important to note that extraneous variables don't always affect a study. So it is thought, for example, because they affect all individuals, it's also thought that they might affect some individuals in a negative manner. And so, for example, some individuals might have better sleep, while others might have worse sleep. So because the direction of the way it affects the outcome is different, sometimes it is thought that it might not actually make the study irrelevant. So another thing to consider is experimental bias. So what are some examples of bias? Well, this picture shows many of the types of bias that can be found in clinical research. And I'm not going to get into them, maybe in another video, but there's some types of bias which aren't so readily apparent. So, for example, you might think that, obviously, if I was doing a study in spatial intelligence, maybe if I have all the young people in one group and all the old people in another group, the young people might be able to have a better reaction time, and that's quite relevant. But in some areas of research, this can actually be a problem. So, for example, if I'm measuring the efficacy of a new surgery, a surgeon that measures the efficacy of a new surgery, they might unconsciously make the choice to only provide that surgery to people that are young, because the old people, or people that are older, it might be unethical, or there might be a higher rate of death or injury to that. And this isn't like a conscious thing. The surgeon might not deliberately be making these two confounding groups. Now, moving on to ethics. Now, ethics can actually be a variety of things, and the most common framework for looking at ethics within healthcare is the four principles: beneficence, non-maleficence, autonomy, and justice, which can be considered in a variety of aspects, as you see in the pictures before you. Although ethics can also be considered in other aspects. So, for example, considerations of people's religious views. There's a lot to think about on this.